I will bring mint, and that's it. Is that enough? Okay, now the whole point is, just when you're taking the test, you're licking or put on the dum-dum or something, don't get the whole bucket of it, because now you overload your system, it's going the other way. If you have a sugar high, then you cannot concentrate. Now, if I remember correctly, where do we start? Right here? Right. Okay, just refresh your memory. We are just in the introduction, right? We know that the brain has three major components to it: the cerebrum, the cerebellum, and the brainstem. And then we learned that we have, in development, we have primary vesicle and we have secondary vesicle. In the primary, it's usually about 26 days after conception, you have a little boat coming out. Remember the name of those three? Proencephalon, mesencephalon, and rhinencephalon. And then they develop from the telencephalon, they develop into, from proencephalon, they develop into telencephalon and diencephalon. Mesencephalon stay the same. And then the rhinencephalon will give rise to mesencephalon and myelencephalon. You remember that? And from there we learned that your cerebrum derived from the telencephalon. Your thalamus, hypothalamus, epithalamus came from the diencephalon and so on. Is it easy to remember? And we also talk about the ventricular system. Remember the cavity that contains the CSF inside? Right? Okay. In the telencephalon, what ventricle you have? The lateral ventricle. In the diencephalon, you have the third ventricle. Right? In the mesencephalon, you have the cerebral aqueduct. The fourth ventricle found in the mesencephalon, myencephalon. Remember that? Okay. And this is what the process we have learned already, that this takes place from all those 5 subdivisions. They develop, and look at that, the most developed one is the telencephalon, and that's what the brain looks like when we are born. Okay, we covered this slide already. Now, we also talk about that when we discuss the gray matter and the white matter in the last chapter. In your spinal cord, the normal organization, the gray matter stay in the middle, and then the white matter surround them. You remember that? And that's true. But when you go up to the brainstem, have you noticed that the organization stay the same? Gray matter in the middle, and by the way, you see the central canal, and the white matter surround them. But look at the size of the white matter. They are much bigger. Why is that? Really simple. Because remember that the whole thing about spinal cord is they carry information from the body to the brain. So when you look at the spinal cord at your lumbar level, it only receives information from your leg and maybe your pelvic. And when you go further up, now you have the gut coming in, now you have the thoracic coming in. And by the time the brainstem, by the time the spinal cord enters into your skull and become the brainstem, everything now reported to the brain. Therefore, they're big. Remember, spinal cord, the white matter are the cable that carry all information coming in. When you enter into the cerebrum, the orientation stays the same, but they add one more gray matter on the outer layer. Okay, and that gray matter on the outer layer, we call that the cortex. Okay. Now this is the actual ventricular system that you can view from the anterior view, or you can see from the sagittal view as well. You only learn from the ventricular system that you have the lateral, the third, and so on. Here's exactly what they look like inside the brain. The area that painted blue is the ventricular system, the cavity. Let's talk about lateral ventricle. You cannot miss that. From the anterior view, it looks like the horn of the rat. You can see that? Okay? It's big. From that, and look at the sagittal view. It's so big that they separate into different structure. This bulking on the anterior side, we call that the anterior. I cannot stand this thing.